And being passed around for the students taking this for credit is a syllabus and a sign-in sheet. So if you could be sure to sign in. The system is the same as last quarter. Those of you who are new, feel free to see me afterwards and I can explain the grading system. It's pretty straightforward. But what we'd like to do now is introduce Scott Rutherford, our speaker for today. He's a professor and chair of the Civil and Environmental Engineering Department at the University of Washington. And we really appreciate him making the trip down to Portland today. So I'm going to express that appreciation by turning it over to you. Scott.
Okay. Thanks, Rob. It's very nice to be here. The good news is I came. The bad news is I left my voice in Seattle. So we'll see how this works out. I didn't say anything all morning to see if I could sort of get enough in reserve. So my interest areas are public transportation, transportation planning, demand management, those kinds of things. And I worked as a consultant in Washington, D.C. for about 6 years, and I worked a lot with a fellow named Sam Zimmerman, who's the primary author on the paper I just handed out, and who then was the director of planning for the Urban Mass Transit Administration. And he and I have worked together off and on for over 20 years. We're working on 2 projects now, one for the Transit Cooperative Research Program of Transportation Research Board on developing guidelines for implementation of bus rapid transit, and that's the basis of my talk today. Also, a part of that contract was the development of a video database, and that little sort of quarter-sized piece of paper I handed out. This one is the sort of instructions on how to get on the web and search that database for images. We're adding some all the time, and also we're turning it over now to the University of South Florida is going to maintain it in the next couple of months. So what I want to do today is sort of go through the concept of bus rapid transit, and it's sort of what we call in the transportation field the mode of the month. And there's a lot of excitement, a lot of conferences, and it goes along like that for a while, and we'll find a new mode or rediscover a mode, I guess, to be more appropriate. So, and we're going to talk about what is it, what are its features, and what are the benefits, and sort of from the standpoint of implementing bus rapid transit. The planning for bus rapid transit is the same as for any rapid transit system. Basically, we're not sort of saying that bus rapid transit is some miracle mode. That's far from the truth. It's not that. What we want to do is emphasize that it's just another sort of arrow in our quiver of solutions that we might apply to solve transportation problems. And it can be very high performance, excellent quality. I think that's what's coming out. I mean, people are educated about some of the aspects of bus rapid transit they just hadn't thought of before because it has been implemented other places very successfully. And one of the main things about bus rapid transit is it sort of has this sort of concept of fixed facilities, but also is flexible. It has a permanent thing. So one of the problems we've always had with buses is that you can't tell where they're going to go. You go out and get on a bus, and the first thing it does, of course, is turn right when you want to go straight. Well, that's not the case with a light rail or the trolley we have outside here. You can know exactly where it's going to go, but it's not going to take a right turn suddenly and go down the street where the tracks don't go. So a lot of what bus rapid transit does is provides buses with that same kind of permanence image. And we package bus rapid transit to match the market. That is, how many people, what times of day, etc., and also the physical environment that's there. And bus rapid transit is a mode that can fit in environments that other fixed modes can't. For example, you might have a bus rapid transit system that's in a tunnel in the downtown, and then a separated right-of-way as it gets out of the downtown, and then on arterial streets for a while, and then another separated right-of-way. It can do that. The key attributes of bus rapid transit, one is speed. If it's going to be called rapid, it's got to be fast. So it's more reliable than typical buses, just like rail's more reliable than standard buses. It's got this identity and image that's different than the rest of the buses. And you'll see that as we go through this presentation. That's a big thing about bus rapid transit. It's got to have this kind of image and identity. And it's sort of designed to fit into its environment that it's existing in. So the elements, if a bus rapid transit system has all of these elements, and we're going to go through each one of these. That's stop stations, vehicles, running ways, how the bus gets up and down, what types of services it provides, intelligent transportation system applications in bus rapid transit is important, and also fare collection. So let's look at each one of those. Stop stations and terminals. These emphasize permanence. There's substantial investments. We're not talking about just a sign on the telephone pole that says the number 46 bus stops here sometimes, or did at one point. It's weather protection. These are stations like you'd see in rail systems, maybe better than some rail systems. The stations and stops might have amenities and of course, passenger information, hopefully real-time passenger information. Amenities might be things like something as little as a snack shop, a telephone. That's a big inspiration for a lot of transit. Maybe even a bathroom. Oh, that's a bad one too. But it would have some kind of package of amenities that's appropriate for that particular site. It's safe and secure. One of the things about amenities, if they're human-occupied amenities, it makes the site a lot safer. I used to work on trying to get people to put services near park and ride lots, so there was some kind of a presence at park and ride lots, because when you leave your car in a park and ride lot, all the thieves in the county know that it's going to be there from 9 to 4, and there's no one else going to be in that lot. But if you have sort of a retail, a coffee shop or something like that there, it has a pair of eyes out there that can help. And so this is the same idea here. And the stop station and terminal also convey this image about what the bus rapid transit is. And again, it's designed to be sort of integrated in with the surroundings. I have some examples of these things. Here's a bus rapid transit station in Paris. So obviously you have to sort of fit them into the physical environment that you have, and there was a very narrow environment, and that's their treatment. Here's several different ones from the Brisbane Southeast Busway. Fairly new, goes through a university. It's on the right-hand side of the screen there. You see the university. It has a theme that sort of carries out through the whole system. So, oh yeah, that's a bus rapid transit station. It's obvious. Here's one in Colombia. See in the bottom left there's sort of platform loading, basically. So you're walking straight across. Very similar to a rail system. And the cars have to be able to sort of dock at that station to do that, and I'll talk about that later. So the second thing then is the running ways, or some people would say right-of-way or roadway or whatever you want to call it. I mentioned before that BRT can operate in a wide variety of running ways. It can be all by itself in a tunnel or elevated, real expensive, can be on arterial streets, can be on an HOV lane, can be on contraflow lanes, can be just about anywhere that a vehicle can operate. The running way is probably the most important thing in regards to the speed and reliability of the bus rapid transit system. So we're looking for separated facilities whenever we can get them. Whenever we can get them, we'd like them to be separated. And if not, there's all these other treatments we'll look at, but we would like them to be separate. Here's an example of a running way in France again, where this one obviously has a lot of identity. I don't know if I would do that. I don't know if I'd want that in my neighborhood, but it's clearly that's where the bus goes. Here's one in Vancouver BC. Maybe some of you have been up there to see that. It's the 99 Beeline. It opened just last year. And it runs from downtown Vancouver south to Richmond. And it goes through all kinds of different rights-of-way. It sort of does this loop through the downtown. They don't use their downtown busway, but they just do a loop. And in some places it's just on an arterial street. Some places it has a queue jump. Some places it has signal priority. In other places, like in Richmond, it has its own right-of-way that goes right down the middle of the major arterial. And that's what's depicted there. Here's Pittsburgh, the Martin Luther King busway, goes out to the east of downtown Pittsburgh. Pittsburgh is the one place in the United States that has sort of furthest ahead in busways. I mean, they started doing it 20 years ago. They have 3 busways, one that goes south, one that goes west towards the airport, and one that goes east, and they're still building these things. And their concept, and they also have a light rail. the one that goes south shares a lot of its right-of-way with the light rail system. In fact, it shares a tunnel that goes through this big hill that overlooks the river. And what happens is it comes through the tunnel, the bus and the train comes through the tunnel, and the train goes in a subway through the downtown, and the bus gets out of the right-of-way and does what we call a counterflow loop through downtown Pittsburgh. Pittsburgh has a one-way grid of streets, and they have this loop that goes against traffic all the way around. So one of the problems we always have with HOV lanes or bus lanes in the downtown is that there's always a UPS truck parked there. Well, the counterflow lanes are the lanes that go the opposite way from where the traffic's going, and people don't get in there. That's just not a problem. They're kind of what we call self-enforcing. So sort of they get out of the gene pool pretty fast if they get in that. Another example in Houston, Texas, an expensive example of getting the bus and people between a park and ride lot in the center busway lanes. And these can cost, $100 million or so. Very expensive. But when you're in Texas, it's okay. Here's a couple of other examples of guidance for the busway. Now, the busway can be just like a road. The busway can have mechanical guidance, where the bus has little tires that sort of stick out from the side of the bus and touch a curb, and that curb guides the bus. And we have several examples of those around the world, in Australia and France, of guided buses. In Seattle, when we built the downtown bus tunnel, we looked very carefully at that technology because it makes the right-of-way smaller. And when you're doing tunnels, every inch of a tunnel you can saves you a lot of money. So we looked at that, but they were having these dual-mode buses, electric diesel buses, and they just didn't think they wanted to take that kind of technology leap all in one fell swoop, so they left off the guidance. So, but you see them other places. There's also optical guided buses. This one on the right is in France, in those little sort of lines painted on the roadway there. Those aren't to separate the vehicles. Those are to guide the vehicle. That goes right over the bus, goes right over the top of those, and with a little camera looks down and keeps the bus in its lane. And what these do here is that since they're trying to get in there and get really close to that station, so there's no gap between the station and the vehicle, so people don't fall down through there, things like that, they use the optical guidance to sort of dock the vehicle and then take it away from the station, and then the operator takes over. Okay, so they sort of comes in there, the system takes over the vehicle and brings it right in, right on the money. People get in, it takes it away, and then it turns it over to the operator. That's how they. And the one on the left is a mechanically guided bus. Here's another example, and this is sort of a higher clip. Really a huge, very big right-of-way for a busway. It's 4 lanes, so buses can pass each other. But in South America, they have just horrendously large volumes on their bus systems. It's amazing. It's really amazing. So they can justify something like this. And I know I went to a seminar one time in Seattle with this Jaime Lerner, who was the mayor of it's called Curitiba, which is real famous because of its busways. And they go out there and he says, well, we just, Friday the traffic goes away, and by the time it comes back on Monday, it's not an arterial anymore, it's the busway. They just, over the weekend, sort of put this thing, imagine us trying to do something like that. My whole career has been trying to develop some things like that. So somebody raised their hand and goes, well, how were you able to do that? And he goes, first we killed all the traffic engineers. I expect there's some truth in there. But. Another example of a bus tunnel in Brisbane. So there are some of these around. Seattle's is about 1.3 miles long. It's worth about $1 billion in today's dollars. It's a lot of money for a mile. $1 billion a mile. But you can do it. Vehicles. They're always rubber tired, and they can, like I mentioned, they can be either steered or guided by optically or mechanically. And there's all kinds of different buses. That's one thing about bus rapid transit. It can accommodate a whole range of vehicles on its right of way. because it doesn't have to be a certain width vehicle or length vehicle. Any vehicle can operate on that can go on a street. It can be regular buses, or you're going to see some examples of some sort of special sort of BRT buses with a different identity and different shapes. And most of the BRT buses are trying to be environmentally friendly with either compressed natural gas or some kind of fuel that's not polluting, and low noise as well. Los Angeles has been sort of on the forefront of implementing bus rapid transit. They had some pretty disastrous experience with some rail systems, at least heavy rail systems, and so they're looking for some other options. And they have a line that goes between downtown Los Angeles and Santa Monica. Lots of buses, every 7 or 9 minutes. There's signal priority. All the buses look like these, and the only ones that look like that in Los Angeles. I was down there last week or the week before last for the Rose Bowl. Ooh, that was ugly. But I was staying in Santa Monica, and I saw lots of these buses out there. And I've been down there twice before to look at this stuff. But they're low floored. You can there's no stairs. It doesn't need a lift. They are sort of like express buses. They don't stop every place, and they have their own terminal, their own sort of stations to stop at. They're different than the other ones, so they have that identity. And they reduce their travel time about 30%. And they also have signal preemption. Well, I'm going to get into some of the details of that later, so I shouldn't go too far now. Here's another example in Paris, an articulated bus with a terminal on the left and the right-of-way on the right. In this case, it's just a single lane, so there's probably another lane on a parallel street. And back to Columbia again. Some of these sort of bus rapid transit sort of looking vehicles with a smile on their face. You can see that. Lots of doors. It's like subways. Get people in and out. So there's some of the buses in South America that carry almost 200 people. Here's some of the bus rapid transit designs. I don't particularly like these very well myself. Looks kind of like a Winnebago with flat tires, but they're trying to do something different, give them some identity. Hey, Keith. And the inside of these buses that you just looked at look like this. They look a lot like subway cars. Not as many seats as standees for certain applications, so that's how you can get 200 people in there. Not that bus, but here's a double articulated bus from France. People have talked about in the past, maybe we ought to have these things sort of get together out in the suburbs, sort of collect people in the suburbs and come to a site and then link up somehow and just have one driver take this big train of buses to downtown. And obviously your own right-of-way would be pretty important if you're doing something like that, but that's could maybe bring 800 people with one driver that way. Another picture of a double articulated bus from Brazil, Curitiba. They have different kinds of services and different kinds of buses there. They're all different colors, so you know just exactly what they are. Fare collection. Really prefer off-board, like rail systems, because it really enhances the boarding experience. It makes it a lot faster. But if we can't, we can accommodate that on board as well. And we're trying to emphasize that we don't want bus rapid transit to be yet another mode that's not integrated in with the rest of the transportation system in the region. So consciously we'll make an effort to sort of have our cards accommodate other people's systems. It's really hard to do that, as it turns out, but institutionally it's hard to do that. Technically it's not hard to do that, but institutionally it's very hard to get people together. Here's in Bogota, they have like a subway kind of fare collection system there. In Curitiba, they load people into these big plexiglass tubes where people pay their fares and then wait in this tube, and the bus comes by and they get on the bus. But the downside of that is there's an attendant in every tube too, and so in this country that would be unthinkable. Smart cards. mean, there's all kinds of technology. I mean, mag stripes is what came first. I mean, it really came when they built BART. Well, I think that's the first mag stripe I can think of. And bus systems are typically using those now, and smart cards are coming along now. It was either smart cards. This one's from Washington D.C. and just touch it to the machine and it reads you. And there's other smart cards where you just have to get within sort of proximity and it reads you. Like the people, I mean, for years have had those things for building security, right? So if you're a woman, you might have it in your purse and you just sort of go by the little reader, or you might go bump it up with your wallet or something like that. They can be set so they can read pretty big distances. I mean, the same kinds of technologies as the technology that's taking tolls off of cars for traveling on freeways. So there's one story where they said that they're testing this stuff out, and the bus comes up to the bus stop and opens the door and read everybody's card as they were standing on the sidewalk. So that's a little bit too high, probably. Intelligent transportation systems. A whole lot of different things help implement bus rapid transit. Automatic vehicle location, AVL. It gives us the capability to sort of manage the system, keep the buses spaced apart, tell our customers where the buses are. I mean, we sometimes are very reluctant to do that. I don't know why. You know, the transit company knows where the buses are, but we don't want to tell anybody out there that's standing at a bus stop waiting for one. Passenger information derived from the vehicle location. Safety and security aspects of ITS and surveillance and things like that. Signal priority at the stops, the intersections. Communication systems. ITS related to fare collection, like we said, the smart cards. And I think the next step is sort of just have some credit card company collect our fares, right? We'll just have to do it, or we'll take our Visa card and go like that, and then everybody will have a card. We don't have to worry about somebody distributing yet another card in your wallet. You know, it gets so thick, and pretty soon you can't even hardly stand up. So it'd be nice to have fewer cards, I think. And then ITS relates to the vehicle guidance and control. Really, ITS started out in the sort of like 1986. I remember I was involved with it. It was really people trying to automate cars, basically. That was the motivation. And it came mostly from California. They had done a study that said, well, it looks like it's cheaper to automate than to double deck all the freeways. And so they launched into this big effort. And the automated car thing has kind of faded from the scene. It didn't kind of meet the laugh test, actually. But a lot of the technologies associated with that, like telling us where our vehicle is and where other vehicles are, not allowing us to crash into a car in front of us because we have radar brakes, and there's a lot of different things that come out of that program that we can employ in bus rapid transit. It's probably a more appropriate place because we have sort of control of all the vehicles. Well, this is Los Angeles, and they have this sort of low-tech control room because there's only one line at this point, where they look on that TV screen and see where every bus is between downtown Los Angeles and Santa Monica, and try to keep them spaced out. Now, they're about it depends on the time of day, but let's say every 10 minutes there's a bus. And so what they're trying to do is to have a bus come every 10 minutes, not 3 buses come every 30 minutes, is what often happens in urban transit systems. And so they monitor this, and they can give the operators a little more green if they're behind schedule at the intersection. So there's signal priority if they're behind schedule, and if they're not behind schedule, you don't give them signal priority. You sort of don't want them running too fast or bunching up. So they're making a big effort. Of course, when you talk about one line, that's one thing, and the whole system is something completely different. But they're making that effort. And this is sort of a little close-up of what the operator sees in the buses. Nice detail on the bus there, too. Here's a signal priority example in Vancouver and at Bus Rapid Transit, the 98 Beeline. It's in the center of this right-of-way, and you see all those signals there. And as it turns out, the drivers are really confused at this intersection. I mean, really confused. There's too many lights and too many options. And some people are going down the busway, and other people are turning in front of the buses. And so whether or not that shows sort of like it takes a while to get people trained, maybe. this one might be a bad example of what to do. Information systems. This is a sort of display at the Northgate Transit Center in Seattle. It's a sort of a major transit destination point, and it tells you, about all the buses in real time. In real time, it's not a schedule. It sort of says this is where the buses really are. So if the top one, the number 5, says it's scheduled to leave for downtown Seattle at 10:45, it's going to leave at 10:45. It's on time. And see another one that's the number 41 to downtown Seattle's 27-minute delay. Now what's with that? Whoa, that's terrible. So they have 2 of these systems in Seattle that was developed by a fellow in our electrical engineering department, and this is one of them called BusView. And they have another one that is a companion that shows you for any sort of area you want in the county where all the buses are on the network. So you can sort of slice out your house or your job place around it, and so you can watch the buses communicating through the network. And I found when I'm on campus, maybe late at night, and the buses are sort of doing 1-hour headways, it's real important not to miss the bus. And so I can have both those screens. I can get them all on one screen, and I can watch, and I can see as they're saying, well, it's going to be on time, or it's going to be 2 minutes late, and oops, here comes the bus on campus, and I know when I have to get up, put my coat on, and walk to the bus stop. I wait like 20 seconds, and the bus is there. That's the kind of service that everybody ought to have. And in fact, in Seattle, everybody does have that, but nobody knows it, because nobody knows about this. I mean, Metro doesn't really publicize it very well. And when I tell people about it, they go, "Oh, that's really cool." And also the same information you can get on your Palm Pilot and your cell phone as well.
So I'm sorry, this is web available?
Yeah. If you go to the King County Metro website in a persistent, you'll find it. It's called BusView and My Bus. It's over on the left-hand side, but it's just, I don't know if they're embarrassed about it or they don't like you to know their buses are late. I know when I look at it, because there's a lot of the buses that I take originate right by campus, and so when I see a bus sitting over there for 10 minutes and then it's another 4 minutes late, I go, well, what is this? This is nuts. 4 minutes late after that. I always had these, these prescribed union time as for his layover, and yet he's still 4 minutes late. I just don't get it. So I call up my friends down there, and they're a little tired of hearing from me, actually. So other passenger information, in the vehicle as well. One on the left is in Paris, telling people what the stops are. And the one on the right is, where could it be? I mean, it's Mouseland in Tampa. And here's the sort of the control center of that Iris bus, which is the optically guided bus. And you can see right on the front there, you see a camera right there. The camera's looking down at those lines, and it's driving the bus. Now the driver is accelerating and putting on the brakes, but the bus is driving itself. Now around college campuses, you may not want to do this because I can see people painting new lines off into some swimming pool. So who knows? Here's one of these Civis buses with the optical guidance, so it docks at the station, so it gets there so you don't have kids falling down the crack between the bus and the platform. You can easily get on the bus and off the bus. And if you just showed that picture to somebody and didn't tell them what it was, they would assume that was a rail system, I would say. Service, the route structure. The idea here again is to have them that are simple to understand. One of the big advantages that light rails had is like you knew where it went. It just goes from here, here are the stops, and the stops in there. It doesn't do all kinds of sort of loops around to do something. Who knows what it was. So it's simple and direct. And it might be a lot of routes, or it may just be a few, but they have to be able to explain it to people. And I have an example of that in a second. And the routes also obviously might go beyond the busway or the bus running way. So like if you go to a place like in Pittsburgh, so it goes south, You go about 4 or 5 miles on the busway, and then you're beyond the kind of congested area of Pittsburgh, then you're just sort of out there in sort of the streets where the bus runs around and collects all the people. In Toronto, in Ottawa, which has the best busway system in North America by a long way, their bus system operates where they take about 80% of their customers with one-seat rides. That is, no transfers. 80% no transfers. And they do that by having these buses go out and circulate through the network to the neighborhoods, pick up their people, get on the busway, and express to downtown, or very few stops. There are other buses that are on that busway that are stopping at every stop and picking up people that are transferring from other buses that are going over the top of it. So there's all these different services on that same facility. So this is what you'd look at for a bus rapid transit line. It looks like what? Looks like light rail, right? That's kind of the idea. I mean, light rail had a good idea. So maybe we can borrow some of that. We can understand it. Here's one that's a little more complex, but the same idea. It's showing all kinds of different services. This is in Brisbane, Australia again. All kinds of different services on their busway. This is where their buses go. That's how their routes are structured. Where the downtown is obviously at the top of the screen. Level of service. You know, defining what bus rapid transit is kind of a hard thing to do. I mean, everybody has their own definition. It's kind of like you'll know it when you see it kind of a definition. But I like to think it's going to be frequent service, like 10-minute service, so you don't have to have a schedule. And it runs all day. You can count on it. It's frequent service and all-day service. And if you didn't have the demand for that kind of service, well, then you don't really need bus rapid transit probably. You just need a bus. So, like in Los Angeles, at their bus stops, you sit there and it says, there's going to be a bus that leaves here in 5 minutes. Okay. When I go to work, you know, you see people at bus stops along the arterials, and there's 20 people at the bus stop, and everybody's looking down the road, right? Waiting for their bus for 15 minutes. It probably ruins their backs. You know, we could tell them this. We know that information. All you have to do is just tell them, you got 5 minutes. You can, read your book without looking up. You can go get a latte or whatever you want to do. If you have that computer in your bedroom, you can roll over and say, hey, I can sleep another 5 minutes. It's important to some people. It is to me. And then conveying the system, identity, and image. The vehicles are going to have a design. And engineers don't do this part. Okay, the architects and the artists get involved here. And they put in the colors and the graphics and the signage that sort of makes sense. Although I remember when I was living in Washington, D.C., the company I worked for was the design firm that did the Washington Metro. And, of course, we had all kinds of architects, and they did the inside of the stations. And for the signage, they had these, if you've been to Washington, D.C., the signs are on these sort of vertical sort of columns that don't go all the way to the ceiling. They go about 9 feet up. And then on that column is the name of the bus, the name of the stop is written sort of in letters that look good if you go like that. And they insisted that was the way it would be. And so as soon as they turned the station over to the operators, wham, all these signs went up that were like this along the wall so people could actually see them. And so, but anyway, they do some good. So we employ a lot of their services and help the vehicles and also with the stop stations and terminals. Again, design, colors, graphics, those want to have this image of a really nice facility. And then the running way, in terms of what materials it's going to be made out of and how it's going to fit into its surroundings as well. So here's some examples. This is in Brisbane again. I showed you some of these before. You can tell which is the rapid transit station for bus rapid transit. Here's Los Angeles. They have all these unique stations that are just for the bus rapid transit, and they have that real-time information there as well. So you have the red bus, special station, and the real-time information. Not any, and then also signal priority in some cases, but nothing really beyond that. Other than that, it's right on the arterial. In Vancouver, again, the bus on the right is the regular bus. The bus on the left are their bus rapid transit buses. They have stations that look like this one up here in the upper left. Lots of glass so that people feel secure. And low-floor buses. And just a nice package there. And they also have real-time information, and they're going to have off-vehicle fare payment too. The sort of machines are there that there's something they haven't figured out yet, but they're going to do that as well. With bus rapid transit, it's possible that we could have honor fares as well, like you do with light rail. It's the same kind of service. Now, there's been this sort of, the industry has always sort of reacted funny about honor fares with buses because of an experiment they did in Portland. You remember that? There was a sort of a barrier-free, honor system, and the system had the honor, and the passengers had the system, and it didn't work, and so everyone sort of backed off. But this bus rapid transit it's just like light rail, and although you lose some fares there as well, I bring my class down here every year to ride all the different services you have, because we don't have those in Seattle. And I remember one time, several times, they've arrested people. One time the State Patrol arrested somebody, which left a big impression on my class. And one time we got on over there at the Rose Garden station. We were on there, and the fare checker people got on the back, and the whole bus emptied out the front. Now I'm thinking, whoa, is this 99% of compliance? I don't know, but it was really funny. Great educational opportunities there. Other running ways in various parts of the world, and you need to sort of designate those things so that people don't happen down them. I mean, that always happens. When I was in Pittsburgh one Sunday morning, taking slides for things like this, I saw, early Sunday morning, a car with 4 drunk people just go screaming down the busway, and then about 10 minutes later they came back. But so people can get in there. So we got to try to keep them out. Features and benefits. So you have this flexibility. We can have the driver steered or not, and we can operate off the right-of-way or on the right-of-way. I mean, that's the whole idea about bus rapid. That's its biggest selling point. You can build your busway as you can afford it, and it still is a system. In Ottawa, what they did, they started on the outside and kind of built in, and they're always intending to build sort of a Seattle bus tunnel in downtown Ottawa, but it's so expensive they haven't done it. But they have the best system in North America, not even having done that. So it's flexible in terms of the way it's implemented, piece at a time. And also, you can put out pretty small service units. That means you can put out a 10-passenger bus, and that could be on the bus right-of-way as well. Or one of those, triple articulated whatevers we saw in South America. Service implementation and operator flexibility. You can, like I said, like in Ottawa, we can have a lot of people that don't have to transfer. And we know that transfers really hurt ridership. And I'm sure that one transfer is not the same as another transfer, but we know that that when Keith models these things, there's a transfer penalty. And I don't know what he's doing these days, but people have done experiments and a lot of analytical work on that, and it's substantial. I mean, people really don't like to transfer. Now, I have a feeling that a transfer in the middle of the day at a nice, bright transit center is not the same as one sort of at a dowdy intersection in the bowels of the city. But anyway, it certainly is an impediment to attracting a lot of people. Minimum walk distances. I did my dissertation on pedestrians, and they're really pretty lazy. And when you see how far people are willing to walk to transit, it's appalling. You can see why we have problems as a society with our health. But if we want to get those people, we have to give them service that comes close to where they want to go, obviously. Also, we have, like I mentioned before, we have multiple services on a single line, express, every stop, either one. And also just an infinite number of incremental services added to the line. So, speeds and things like that. this is some stuff that was put out by the General Accounting Office in a report they did on bus rapid transit. So you have to take this with a grain of salt, because for a lot of reasons. These numbers are hard to really measure. But the idea here is that, you know, bus rapid transit can be pretty fast. Can be pretty fast and competitive with other rail systems. It all depends on the right-of-way. Modest implementation cost. I mean, you can spend as much as you want. You can make it more expensive than rail if you want, because the tunnels are bigger if you're going to put it in a subway. And Seattle was doing their analysis between light rail versus buses. You know, the buses kind of got knocked because they had to have bigger tunnels, and tunnels are expensive. Excuse me. But you don't have to have them in tunnels. Like I said, you could use pieces of the existing rights of way. They had a particularly troubling area that says you just can't get a 3 blocks worth of bus lane here because it's a commercial area. You know, maybe you look at the whole street in a different light, and the bus just integrates with regular traffic for that 3 blocks and then goes on in a busway after that. And that's fine. I mean, sure, it takes a little time to get through that spot, but it doesn't mean you can't implement that busway through the corridor. So it's flexible in that standpoint. The vehicles, you know, the vehicles are sort of in the 400,000 to 1 million range, I guess. But you really have to order them to find out for sure. Implementation costs. And here's where it's really hard to make comparisons, because the only way you can really make a valid comparison of these things is to do it at the same site, right? You can't take an implementation cost in Los Angeles and compare it to one in Butte, Montana, for example. So these are just, you know, broad ranges. But like I said, if you Brisbane Southeast Busway, 19 million a mile, that's pretty cheap in terms of rapid transit. But if you had a tunnel through downtown Brisbane and it was like Metro's tunnel, it would be $1 billion. So you can see how this little change like that could radically affect how much it costs per mile. So I'm not going to dwell on these, but I just want to show you what people have done. The operating speeds for the buses in a place like Ottawa that do the skip stops are very high. Very high. They're going 55 miles an hour, stopping about every 3 or 4 miles. Their overall speed is really pretty good. And that's one of the big advantages if you can have that kind of service. And the service, since we have such small units, I mean, the bus is a pretty small unit, it can be tailored very easily to the demand that's out there. And the streets are sort of like, the buses run on streets that look like all the other streets that our public works people maintain. The buses mechanically are the same as the regular buses, so they're, you don't have to have some special mechanics to come maintain them, etc. So it keeps the cost down. It also makes it amenable to bidding. So if you're having something like Seattle's doing right now and saying, well, we're going to have a monorail, and what we have with the old monorail is a system that is impossible to maintain because it's proprietary. It says you want a screw, well, it's $10,000 for that screw. And with systems like that, that's what you find. Well, with bus rapid transit, you have streets and buses, and there's a lot of, like I said, 25 people you can order the buses from. Also, it was pointed out that you don't have to really retrain anybody in your region either, because they're already doing buses in the streets. So it's not like a big technological leap for the working people. Operating and maintenance unit costs, again, this comes from the Federal Transit Administration's database, and I didn't put these numbers together. These were Sam's numbers, but just that's one take on the numbers. Let's put it that way. Different people have different takes on these things. One of the knocks on bus rapid transit was that, well, it doesn't have the capacity. Yeah, well, it turns out that these places like Ottawa and Australia and stuff like that, I mean, it does have the capacity. Sure, it doesn't have the theoretical capacity that some trains do, but no one ever uses that capacity anyway. So you don't really need it. So that's what I see a lot of places. That, well, it doesn't have that sort of capacity for the future, but I think that's not true. And you're mentioning here, again, we could operate platoons of buses if you ever really had that problem, where there was a physical problem of the buses getting through the stations and stuff. We could develop the technology to have buses linked together just like trains. So maximum load point, peak hour, peak direction, Ottawa, 11,000. That's a lot. And those are just buses on roads, separated. I mean, they're separate. Sort of down in a trench, kind of, most of the way. But that's a lot of people. So it compares to like the Green Line in Boston and Washington Metro Rail, the orange-blue line, 16,000. It's heavy. It's heavy rapid transit, like BART. So it compares very well. Now the numbers we see from South America, I just completely discount because we would never put up with that kind of service, like 300 people in a bus kind of thing. We wouldn't do that. They can be. I mean, can a bus be attractive? We were doing some work over in Bellevue, which is on east of Lake Washington, with high school students, and trying to promote them or get them earlier, into sort of ingrained in using public transportation. Like 16-year-old boys is a tough market to convince that buses are a good thing. But they filled out these cards, and one guy said, "I would rather ride with my parents than get on one of your buses." Ooh, And then another guy said, "They should have a sign over the door that says, 'Losers enter here.'" So how do we overcome that? Hard to say. So user perceptions of bus rapid transit. One of the things that's been around for a long time was that there was just some inherent attractiveness of rail over buses. It's just, and I have to admit, I feel that same attraction. But when people look at that, I mean, the best people in the world look at that, they don't find it. What you find is what people are comparing is like some lousy city bus that goes 6 miles an hour for an hour you're on it with BART. Of course people had this rail bias then. But when you compare bus service at the very high end, like in Ottawa, with train service, they can't tell the difference. And sort of when they model how people make that choice, there's no difference in the coefficients. And so this is a big deal that Sam Zimmerman always gets into. And this Dan McFadden has been working on these kinds of models since the BART impact study in 1973, 74, something like that. And he was an economist, and he brought a lot of sort of econometric techniques to transportation that you all probably are studying now if you're taking classes in demand forecasting or anything like that. And he worked on this stuff for years and years and years, and they worked on that model, and they couldn't find that there was any kind of this sort of rail bias. And he got the Nobel Prize. So who am I to say? I mean, I don't have a Nobel Prize. So their conclusion was that the coefficients were the same. Now, there's a lot of people that dispute that, but they don't have Nobel Prizes either. So translating that, this is what it says. Competition with driving, all things being equal, times cost, features, comfortable, on time, fast. Travelers are as likely to choose rapid bus as rapid rail for work trips. But it's got to be comparable. Some of the things that have been done, LA, they had a 30% increase in ridership. on their bus rapid transit. And I think who knows why? Was it the real-time information? Was it the little bit faster bus? And it wasn't, or is it all those things? It's probably all those things. So we don't really know what to invest in when we do an experiment where we change too many things. So a lot of it was because it just became a bus that didn't stop at every block. It was going for a while. I mean, that's so frustrating to stop. So Miami, they had an 80% increase in their ridership and their BRT line. Brisbane, 60%. Vancouver, 20%. And Vancouver's really hasn't started yet. And they started theirs in the middle of a strike, and it didn't work out very well. So, and Vancouver's viewing their bus rapid transit corridors as sort of like pre-SkyTrain, which is their elevated rapid transit system. They're saying, let's build up the demand with bus rapid transit, and then when the demand's up there enough, we'll build one of these SkyTrain lines. And that's the way they also sell it to the communities, which is really important because they felt screwed that they didn't get a SkyTrain line, and these people did and we didn't. Well, we're going to give you this bus rapid transit thing, and you build up the ridership, and then we'll give you a SkyTrain line. So it's marketing. All these features about bus rapid transit can also be attractive to the same kinds of owners and developers that are attracted to light rail. Curitiba has a huge impact on their land use. And they also, they have land use controls as well. But and also Vancouver BC. I've been going up there since 1986 when that line started, and when they had Expo 86. That's why they built it and how they're able to build it actually, because it was pretty controversial. It's incredible to see the development around those rapid transit stations. But it's not just the rapid transit. It's they put it there, and there was land use policies. They have regional government there, even more powerful than yours. In Seattle, we don't have any government, so the neighborhood is the highest authority in Seattle. Pittsburgh East Busway, which goes through a very bad area of Pittsburgh, by the way. A lot of development there. The Denver 16th Street Mall, they contribute to a lot of success. And Brisbane has had some early successes as well. So bus rapid transit can make the same kinds of claims, even though they may not be valid, that light rail does. About all this development. Sort of put your light rail line in and then add up all the building permits for the 3 blocks of the line and say it did that. Well, it probably didn't do that. But like the Moose Lodge renovation, I think they would have renovated it without the light rail. Okay, let's look at Ottawa. I talked quite a bit about it. You see, over on the right is kind of a typical station. The busway's in kind of a trench, it's like 1 story down kind of trench. And people wait over here. And it's cold in Ottawa, too. So there's some places that you can wait protected. And this is an overpass here, a pedestrian overpass. And there's also a vehicle overpass there where the other buses, local buses, be running back and forth like this, letting people out. They'd come down here and get on these busway buses. They have one sort of tunnel area over here, and this is more of an area that just isn't in a trench. But attractive stations, there's no graffiti, and they really keep them up and keep them clean. And there's some pictures of Brisbane, and they've integrated their stops nicely and with some surrounding land uses. And you can see that Brisbane's buses are just like buses. They're just regular old buses. So they didn't feel they needed that extra push. So we can also say things like busway boosts house values. There's lots of studies of light rail lines and house values, and that's another sale point for light rail. People are claiming for the same kinds of things for bus. Here's an ad. So when people start talking about the busway in their real estate ads, you've arrived, right? I live on a bicycle trail in Seattle called the Burke-Gilman Trail. That every time they try to extend it, it's real controversial because we don't want all that crime, and stuff that's going to come with a bike trail. I've never seen anybody on a bike with a TV set on the back. seems kind of silly. I mean, in my house, I think it's more secure because the bike trail is there than if it wasn't there. And it's better than the train that goes by. So these things, these are indicators. You know, they're sort of like people must think these are important. I mean, if they're willing to put that there, you know, willing to admit they live near the busway. And here's some changes in Richmond, in the area of that city that in Vancouver BC, where they put the busway. The busways was right here. And this is where it went. It was just a big arterial before, and now it's a really nicely landscaped busway. You wonder about, when I was up there, I was wondering, how could they take away all that capacity on the major arterial and the parking and stuff? And it's not easy. You know, merchants don't like to give that up. Another one from Brisbane, integrated in. One of the points that we like to make is that it's not cheap. You know, we're not trying to say it's going to be cheap. It's going to be competitive. It's going to be competitive, in some cases cheaper than some of the other modes. And it's important to emphasize this sort of brand identity that bus rapid transit has, so that people can identify with it. So that's our sort of pitch. Now let me tell you a couple things about sort of comments about the presentation, I guess. Nothing else. Excuse me a second. I've been working in this area for about 28 years or so, and part of that time as a consultant, where we went around to cities and did consulting studies on what transportation system they should have. And I've worked in about 15 major cities like that, and I can't think of any place that I went where the client didn't know what they wanted before they started the study. And I thought we were going to get there in Seattle 10 years ago when they were doing this alternatives analysis for what we were going to do, because they started out, they said they're going to hire separate consultants for the bus alternative and for the rail alternative, and let them sort of fight it out in the arena of choice. And I don't know I forget what happened, but it just fizzled. And as soon as the sort of more powerful policymakers decided that rail was it was it. So, yeah, what can you say? It's sort of disappointing. I mean, we'd like to say that we as engineers and planners can go in there and give this totally objective thing, and they're going to take our advice. It doesn't happen very often. It doesn't happen very often. Now the question is, but you can make contributions. You certainly can make contributions. I don't want to be too cynical about it. But I saw a lot of bad rail systems go in, and haven't seen any bad bus systems, but there haven't been very many of those going in yet. One thing about a bus system is that if it goes bad, it's pretty hard to hide and take the buses someplace else. A bad rail system is a little more difficult. I worked on the Miami rapid rail system, where the official forecast was 202,000 people a day. That was the official forecast that they based their application for $1 billion from the federal government. And it got about 36,000. So, kind of a disappointment.
Was that Tri-Rail?
No, Metro Rail.
Questions, hold the button down.
Question was that Tri-Rail? Yeah.
Is there any bias to the federal government for funding of bus rapid transit over light rail, or vice versa?
No, I don't think so. The bias is not in the federal government, it's in Congress. And that's where these projects get picked. The earmarks in the bills is the way most of these projects get done. And federal transit, Gordon Litton, who was the previous administrator, he started this bus rapid transit thing. And but they're still going with it. So it survived administration change. Yeah.
I had a question about environmental impacts. On your little slide, you listed that they would use rubber tires. Aren't those then creating pollution problems where maybe a light rail would have steel wheels?
Mm.
And then it's just a follow-up question. In terms of fuel, most light rail use electricity, and there's an opportunity to have, like say, wind power or solar power with that. What's the
Yeah, well, these buses are all going to have fuel cells.
buses?
The buses are all going to have fuel cells. And maybe they will. Seattle right now is ordering hybrid buses to replace their tunnel buses. They have these tunnel buses now that are these dual mode. They're diesel out on the highway and then electrical when they go through the tunnel because of the fumes and stuff. And so these buses are 12 years old, and they were like 200 prototypes anyway, and they were built by these Italians that used to make airplanes that during World War II they put the airplanes out on the runways as decoys because they couldn't fly them anyway. So we have these buses are half as reliable as our next least reliable bus. They just can't wait to get rid of them. So they're testing a hybrid bus now that looks like it has enough oomph to sort of get through the tunnel and then back out through the tunnel, which is what they have to do. So they don't through route down there. They tested some sort of electrical things that could only get halfway through. But hybrids look pretty good in the interim, and the fuel cells for buses, they're getting really close. I mean, they have some, but I'm talking about commercially close and affordable. And the tires, there's going to be more dust, rubber dust from the buses for sure, but less noise.
I have an email question.
My first email question.
Right. This is from a gentleman at the City of Vancouver. Do you have any suggestions on using a Market Street, San Francisco type layout, running buses in the center of the right of way with skip stops as a first step to total BRT reconstruction versus the Honolulu or Vancouver style with the skip stop buses loading from the curb?
Yeah, I like Market Street. I think it works really well. But it puts a lot of pedestrians out in the middle of the street as well. But no, I think that's a good option. Depends on the geometry of the corridor that you're looking at. I think that dictates what's going to get done more than almost anything. But that's a good point. Yeah.
Like the project you were working on in Miami, the busway there, do you feel like that was a result of poor promotion, like just a low ridership to begin with, or was it a density issue? Or?
Oh, well, it was a heavy rail system, actually. Yeah. Completely grade separated heavy rail system like BART and Washington Metro and Atlanta. Where's all this going? What the rules were then that if you had to get a certain cost effectiveness to be able to get funded, or at least get recommended for funding by the then Urban Mass Transportation Administration. So if you weren't doing your trips for $6 a trip, then you couldn't get funded. So the game was, if you could keep your cost estimate down and your rider forecast up, they're looking at this cost effectiveness number, this cost per new rider. And those costs can get way out of line. And so the federal government is saying, well, we don't want to invest in something that has $30 per new rider. And so what people did was then sort of lowball their cost estimates and goose their forecasts so that number comes down to sort of under $10. I always thought when I was out there watching this that someone's going to go to jail. These people are robbing the federal government of $1 billion. They're defrauding the federal government, basically. That's what else can you say? They're cheating. So, but the thing is that if you didn't cheat, you got nothing. If you cheated, you might get $1 billion. So what do you think people do? I mean, duh. That's I worked in Detroit, and you try to tell Coleman Young that he didn't have enough ridership on his line. Right, he wanted his $1 billion, and he got it. He got it before the study was done. It's like right in the middle of the study. Oh, here's your $1 billion, because Jerry Ford needed it for his campaign, brochure or something like that. I don't know. They never did get it though. He got it given to him, but they didn't actually get it in the end. Yeah.
It sounds like bus rapid transit and light rail transit will serve the same general purposes, but bus rapid transit is less expensive in most cases than light rail. I was wondering if you could talk about, say if that's the case or not, and if there is any situation where you would recommend light rail transit over bus rapid transit.
Yeah, I was really disappointed in Seattle when they didn't build the first leg from downtown to the university. Not just because I work at the university, but I mean that leg has huge demand. I mean just huge demand, and even taking it to Northgate, say, and so they say, well, we're going to go south to show people we can do it. Well, I mean, if you can't do it north, you shouldn't do it at all. Was my that's how I felt about it. I think a lot of it is. I feel that if you can get support for either one of these modes and get it implemented, go for it. I mean, it may not. The differences are pretty small anyway, and I think Portland, has done a great job with implementing a whole lot of great service. At the first line, I'll bet you if you did an honest analysis of it, probably people wouldn't have done it if there was some kind of objective person in the cloud that said, oh, no, I'm sorry, we're not going to do that. And then that may have been a big mistake the way it turned out. But, I think you have to do the study at each location and see where you can get the support. I think that like in the Seattle area, bus rapid transit might work really well going south because the corridor is so huge. So you can sort of spread out, and even going east as well. In fact, there's not very many places that rail would work in Seattle, I don't think. Although if we'd have built rail in 1970, like they'd planned, they voted on it twice, once in 68 and once in 70, and it got turned down. It needed 60%, which is really hard to get for anything, but it got turned down both times. And it would have been a BART-type system. It had been done a long time ago. It would have changed the whole city and the way it developed. And also, the federal government was going to pay for 2/3 of it. And we turned it down, and who got the money? You can't answer. Atlanta. That's our money. Because we had your equivalent of Mark Hatfield when we were doing this study. It was ours. He was chairman of the Senate Finance Committee. So we said, no, we don't want your $1 billion. Give it to Atlanta, and we'll just wallow in our congestion forever. It's hopeless out there. At least there's hope here. Yeah.
I just have a question between the difference between the right-of-way needed for bus rapid rail and light rail. Is there a big difference, or is it about the same?
Yeah, it would be a little bit wider for bus, but if you had it guided, it wouldn't have to be wider at all. I rode on a system over in, this was in north of France, I think, and it was a system where they replaced a sort of very narrow median that had light rail with guided bus. So it fit right in there just great. I forget why they did that, but they did it, and it really demonstrated for me that you can get them in the same right-of-way very easily. Yeah?
Yeah, I have a little trouble thinking of bus rapid transit on the streets and freeways on Los Angeles.
Press the button.
What button? Oh, that button. I got nothing in front of me.
It's like an oxymoron, right?
Yeah, that's what I'm thinking. It's mutually exclusive.
That's why it's gotten so much attention, because we all feel the same way. How could it possibly work?
Yeah, what are the corridors in Los Angeles that you refer to? I've been
Well, it goes from downtown to Santa Monica on Wilshire Boulevard.
That's cool. Yeah.
And essentially, I mean, it goes where the red line was going to go and didn't, because they ran out of money and out of political clout. So you can transfer from the red line right to the bus rapid line. Yeah.
Are there any features of this bus rapid transit system that you might apply to more rural, smaller transit systems?
Well, I doubt it, because unless you've got congestions and you don't usually have that. I mean, some rural town with 30,000 people, maybe through the downtown, that might be interesting, but I wouldn't think the whole system would have to be that way. I think if I had that money, I would spend it on increased service rather than any facilities. Yeah.
Lane County, Oregon is building a busway BRT system and planning it. It is a smaller metropolitan area, but you have a really distinct corridor. Can something like this work there, or would it be more advantageous to do something else?
Oh, I'm sure it'll work there. They're on our panel for this project. Yeah, that's an interesting application. I mean, you don't see that often, and we're all rooting for them. I mean, it will be very interesting. I don't think they're getting the Civis bus, though. They'd looked at it for a while. A lot of the renderings have the Civis bus in there, and I've got a lot of videos and stuff of that on that website. Lane County has some great videos, and I just borrowed them and put them on there. You can get them from them as well, but they have some really neat concepts. And that'll be, the world will come to their doorstep to see how they're doing there. I think they're getting very close to ordering vehicles. Yeah.
I was wondering what the cost difference is in bus passes compared to like a city like Pittsburgh and here in Portland, where it's like $50 a month for a bus pass. And then I was also wondering your personal thoughts on the Vancouver, Washington to Portland, Oregon transit problem.
You mean the cost of bus rapid transit compared to
just the bus pass?
Yeah, it would be the same. It would be just like, I don't see it having a big impact on that.
So it's the same in Pittsburgh
Yeah.
as it is here?
Yeah, I mean, similar, right. Probably less. The further you go east, the more they recover from the fare box. So in Seattle, I don't know what Portland gets, but Seattle gets 22 cents in fares for $1 worth of costs. In the east, they get 40, 50, 60 cents. And then I don't know a lot about that corridor. It was turned down in that one vote. The bridges are really crowded. When I drove down here, I sort of experienced that again. I was thinking, what's this like in rush hour? Because it was, even at 10:30 in the morning, it was pretty bad. It must be bad, but I think that would be a good corridor because it's any place where you can pinch down all the other options and concentrate the demand in one place. That ought to do really well. Yeah.
I was wondering if you knew at all about the Silver Line in Boston, how that's been going. I used to live there, but haven't been following.
Yeah, it started, and it's one of the case studies that we did for this project, and it's doing really well. Yeah, that's another interesting one. There's about officially, I think, 16 or so demonstration projects going on around the country that weren't, well, they got some money from the federal government, but it was like just chump change, like $60,000 for a study or something, but it was enough to sort of give them the kind of prestige they needed to get the money to do these things. And and they're all different kinds of projects, very different projects. So we'll get a good look at what bus rapid transit can do across many different applications. Yeah.
I guess this is sort of a political question. Do you think that proponents for bus rapid transit have a lot more power, maybe because of Detroit and the car industry in America? So they're making buses.
No, well, no, I don't think that. 60 years ago, that was true when they demolished all of the trolley lines in the country, and General Motors and Firestone and Standard Oil, and got convicted of a antitrust violation and got fined something like $50. It was terrible. They've never recovered. At least General Motors hasn't. Yeah, no, I don't think so. The bus manufacturers are pretty dispersed now, and I don't. That couldn't overcome the sort of desire for rail that exists among all the politicians. It's really hard to get over that. Are we going to be a world-class city and have a professional team in a light rail system or not? That's stuff that you have a hard time putting in your analysis. Yeah.
Yeah, I was surprised when you said you thought Seattle would be a lot different today if they had sort of a BART-like heavy rail system. I think of DC or I think of BART and their effect on land use, and I don't see why it would be much different.
Well, it has a lot of difference in San Francisco. Not in the city of San Francisco, but certainly outside the city. And in D.C., too, there's not a lot in D.C., but just across the line, a huge impacts there. I lived right between two stops on Connecticut Avenue in D.C., and there was a lot of pressure for development in that area. It's right by the National Zoo, or if you're familiar with that area, and our neighborhood fought them to death about no density. All the buildings got redone. They got redone in the same height that they were before, 1 or 2 stories. And from my standpoint, I'm going, we have to do this. America is paying for this line. We have to have some density here to make it work. But, no one bought it. But further out, like Bethesda, I wasn't there for about 10 years. And I went there to meet a friend and came up through the summer. I didn't have any idea where I was. It was just totally like coming up in a European city you've never been to before. Had no idea where I was. I lived there for 6 years.
I had a question.
Yeah.
My question is about vehicle suppliers. I know in Eugene they've been having some trouble in the decision-making process trying to get the right vehicle, and the Buy America requirements have created some interesting challenges. But do you think the vehicles are coming online that will serve the needs of cities wanting to implement BRT?
Yeah, I think so. That Seattle, when they bought these dual-mode buses from Breda in Italy, they had a big Buy America problem too, and so they just shipped all the parts over to Issaquah and they put it together there, and then the federal government just looked the other way because it still didn't meet the requirements, as far as I know. And yeah, they might at some point. You think you have to change that law. It's just maybe with the European Union they may get enough clout to say, hey, listen, we're going to start doing that too. You can build your Boeing planes over here if we're going to buy any of those, and may not have to since their Airbus is wiping them out anyway. So.
Yeah. Are there any examples of BRT that works as a feeder to a light rail?
Yeah, that could be, where the light rail stops 4 miles out and then it's bus rapid transit. And the best example of that's in Miami, where south, this metro rail system that attracts 36,000 people a day, it stops and it continues way down south on a bus rapid transit line that's been pretty successful. Yeah, so that would be a good application. It also would be a good application for bus rapid transit would, do the cross streets in with rail. Yeah.
Would that be also a good opportunity for like steep slopes? Do bus rapid transit do better on slopes?
Yeah, they do. Yeah, so some places like in Montreal, where they had to go under the river, they used that French rubber-tired system because they needed to. For situations like that, it would be very handy. Yeah.
if I didn't have any dedicated right-of-way for the bus system to work on, but I had the fancy stops, I had the cool-looking buses, do I still have bus rapid transit?
Well, Los Angeles has bus rapid transit, and they don't have any right-of-way. They're just out there slugging it out. Although they have so many buses out there that people stay out of that lane. So they sort of get their own lane almost by accident. Yeah.
How well would bus rapid transit work in an HOV lane situation like up in Seattle?
Yeah. Yeah, that's certainly much better than being in the general purpose lane. And I think that would be a good application. And also because in a lot of cases you can give, in some cases you can give the buses center, well, they're building the center access to those HOV lanes now, and that's, again, it's really expensive. But if you're going to have a HOV bus-based system, you got to pay it, $50–60 million on an intersection.
One follow-up.
Yeah.
Are there cases where people do that? And do they get on and off to service the stations?
Yeah. Yeah, the alternative is to drop everybody in the middle of the freeway and make them walk to their cars, or drive off the freeway and delay the bus. And so there's a lot of tension between the service people and the bus operators. Man, let them walk. Sometimes those freeway areas are not very hospitable places, and especially when it's raining. Yeah.
I'm curious about, some of the buses look very futuristic and some of them look just like a regular bus. And I imagine one of the more futuristic ones are more expensive, but at the same time they act as selling points to the public.
Yeah.
But in terms of ridership, I'm curious as to what kind of market segment do they really serve. There's perhaps a hypothesis that light rail will appeal to more suburban tastes than a regular bus. Same here, perhaps with the streetcar. Will make them pretty, people will ride them. I wonder if there are any studies that compare the ridership of a BRT versus a LRT.
Yeah, they just haven't been around long enough for that. There's an infancy here, so they need a lot of master's theses to find that out. That was the first time I saw the trolley go through here. And did the whole campus come up after the trolley was here? It's really cute. Yeah.
Are people really leaving their cars behind? I mean, I'm not. Is there a displacement that's been identified using buses, rapid transit instead of their cars?
Yeah. Yeah, there's been several. Our case study has found several places where they've measured that, and they're finding 30 and 40% of the people were former auto drivers' work trips. Because one of the things that people beat us up on when you want to put in a higher level system like light rail or bus rapid transit is that, well, everybody that rides it was riding it before. So what have you gained? Well, you build a new freeway, and everyone that's on that was driving their car before too. So should you not build freeways because of that? These arguments have to be turned around, I think. And we're providing a better level of service for people. Yeah.
What's the trip purpose distribution? Is it mainly commute to work type thing?
Yeah. Except that since it has all-day service, you don't get that sort of peak of the work group. Yeah.
You mentioned at some point that with bus rapid transit there would be shorter walks and no transfers. But what about bus rapid transit makes that true versus other forms?
Yeah, well, like the service in Ottawa, it goes along the busway, but can get off at different points. So it gets off and then goes on local streets and picks up people close to their homes, and then gets back on and goes express, so they don't have to transfer. Although the transfers at Ottawa are not that bad because when there's a bus every 3 minutes, by the time you get from your bus to the platform, 10 buses might have gone by. So you feel pretty good about it. I lived in San Francisco, and I always felt good there because I walked down to my bus stop, and I wouldn't run for a bus because there was I could see the next bus coming, always. So when you have that level of service, then maybe transfers aren't so bad. What do you think, Keith? Is that would you change your model for that? Yeah.
Well, we will express our appreciation in a moment, but I want to just make a couple announcements. Next week, we have Rick Gustafson and Jerry Mildner continuing on the transit theme, doing a point-counterpoint on rail transit. So look forward to seeing you then. Students who are enrolled in the class should be sure to grab a syllabus and to sign in. And if you have questions about the credit process, please see me afterwards. And also, I have a number of research assistantships available, and also in my email inbox, I think about 3 or 4 internships, including some at some top agencies and consulting firms in this region. So if anyone's interested in learning more, please contact me. There are lots of opportunities to get paid out there right now. So look forward to that, and let's thank Scott very much for his presentation.
So your economy's back here because in Seattle it's like yeah. Thank you. Good to see you.
Good to see you. You're looking well.
Thanks.
How do you stay so skinny?
I lost 22 pounds.
I was going to say you look a hell of a lot thinner.
Yeah, I feel a lot better too. My wife went on Weight Watchers in July, and I lost the weight.
She didn't?
Yeah, she lost about 12. But, I can't.